Let's learn about mechanical energy with skateboards. So mechanical energy is energy possessed by objects based on its position or its motion. So based on its position is also called potential energy. So a skateboard at the top of a hill was the potential to move downhill. And so releasing the skateboard causes the potential energy to transform into another form of energy called kinetic energy, or the energy of motion. And we are very grateful that it happens because skateboarding is fun. Potential energy is always being transformed into kinetic energy. When something is released, it falls and becomes kinetic energy, and you can see the difference that something with more potential to move down has more bounce or reaction, so therefore has more action, more force.
So if we're talking about potential energy, right now I'm at the top of this hill here, and if potential energy is stored energy, stored kinetic energy, then we just have to find a way to release it. And with skateboards, it's pretty easy. You just have to point yourself downhill so that friction and gravitational energy are overcome by the force that you're on. And as you can see, the faster you go, the more you're releasing potential energy and converting it into kinetic energy.
So we can see that potential energy is the energy due to the position of an object. So like the ball at the top of the hill, you can see it turns totally yellow, which means that it no longer is moving. It doesn't have the kinetic energy of motion at that point, not much anyways, and instead all of its energy is stored in the position or the ability for it to roll down the hill. And the kinetic energy, the energy of motion, takes up all of that. So at the bottom where it flattens out on either edge here, you can see that it is not yellow, meaning it doesn't have any more potential to move after it stops rolling. It has no more potential. It instead just has the motion that it has. So I hope this video helps show the difference between potential and kinetic energy and how they interplay in mechanical energy, which is both sides of this single coin.